Last class we discussed about so good morning to everyone. Last class we discussed about the operational amplifiers or the high gain DC amplifier and high input impedance, low output impedance. So amplifier is nothing but, so here it is an electronic device, or otherwise I told to you that it is an integrated circuit chip, IC chip. Simply we can call it as IC chip. In this IC chip, 2 dozen transistors, 1 dozen resistors, and 1 or 2 capacitors are there. So here it is a configuration, 8-pin configuration, and one is the inverting end, the other one is a non-inverting end, and 2 offset null, and negative voltage supply, positive voltage supply, and the output. One another one is a neutral. Then ideal amplifier is an infinite voltage gain, means infinite output impedance, infinite input impedance, zero output impedance. That is the ideal amplifier. But so in that amplifier, we discussed so many examples. That is a differentiator, summing amplifier, inverter, inverting amplifier, voltage follower or buffer amplifier, differentiator, differential amplifier. So these are all we discussed. The last previous class we discussed, right? So in the examination, if they ask me, so you can write any 2 or 3 amplifiers, maybe inverting or summing amplifier, and then you can take one differential amplifier also. I told you the differential amplifier is to reduce the noise. Reduce the noise. So now today's class we are going to discussing about the filters and analog signal conditioning. Filters, all of you know that filters, right? Filters, it is an electronic device that it removes a certain band of frequencies from a signal and permitting others. It is called a filter. All of you know that filter. See here, generally the word filter is nothing but, for example, if you see in our household appliances, water filter is there, right? So what is the meaning of water filter here? So whatever the dust particles, it will be removed and then we can get the pure water. That is called filter. Same similarly here also. So that means this filter allows certain band of frequencies from a signal, and the other are removing that there is a certain band of frequencies from a signal or passing, and the other are eliminating. These are eliminating are unwanted signals. That is, unwanted frequencies from a signal are eliminated, are deleted, are removed. So here the filters, for example, if you take the MSET examination, if you take example, MSET examination. See here for MSET around 2 lakhs students are writing. So in that those who are having much more knowledge, and they are filtering through the ranks. So for example, only 50,000 or 70,000 people are allowed to study the engineering course. Example. That means for around 2 lakhs people are writing the exam of MSET. Only some of the people are studying engineering. That means filtering. The filtering means, so that is also is one of the filter example. So here also in this filters, the filter is nothing but it is an electronic component or a device. It allows only a certain band of frequencies from a signal, and the other are removed or eliminated. That those are unwanted signal, unwanted frequencies from a signal. So now it is clear the filter. So in this, it is also known as frequency selective circuit. Is a special type of circuit which is used for filtering out, some of the input signals on the basis of the frequencies, right? So that means here on basis, that means unwanted frequencies from your signals are removed. This causes, it will affect on the output. So here, this unwanted frequencies from a signal, this will causes some the disturbance in output. That means the output is not satisfactory. So here filter, we are using filter. With the help of the filter, we can remove the unwanted frequencies from a signal. Only certain band of frequencies from a signal are permitting to yellow, thereby it is the output is satisfactory or useful. And then here a filter circuit passes some frequency signal without any attenuation. Attenuation means here a reduction in amplitude. Attenuation, that means attenuation, in other words, attenuator, we can also call it as attenuator. Attenuator is nothing but the other word of filter. The filter circuit passes some frequency signals without any attenuation, that means without any disturbance. That is a reduction in amplitude or with some amplification, or attenuate other frequencies depending on the types of the filters. So right, the next, the filters, right? Here the filter, it is used to describe what I said, the process of removing of unwanted frequencies from a signal and permitting other frequencies from a signal or transmitting, right? And here this is a very important, all of you see here, the range of frequencies passed by the filter is known as pass band. Pass band, some range of frequencies from a signal is passed by a filter, that is called a pass band. That band we can call as a pass band. And the range of frequencies not passed by a filter, that means eliminated or removed or deleted from a signal, that is called stop band or reject. That is called stop band or reject. The range of frequencies, again I'm repeating, the range of frequencies from a signal is not passed by the filter, that is called stop band or reject. That means it reject the unwanted frequencies from a signal. Unwanted frequencies from a signal. And here the boundary between the stopping and passing is called the cutoff frequency. Again I'm repeating, all of you listen carefully. The range of frequencies from a signal is passed by a filter is known as pass band. The range of frequencies from a signal is not passed by a filter, that is called stop band or reject. That means eliminated, it eliminated or deleted or removed the unwanted frequencies from a signal, right? That means reject, reject. And the boundary between this stopping and passing is called the cutoff frequency. It's called the cutoff frequency. Here in these types of filters, 4 types of filters is there. Low pass filter, high pass filter, band pass filter, band stop filter. These are the 4 filters. So now we'll discuss one by one. All the filters we'll discuss. See here the low pass filter. It's a very, very simple low pass filter. If you see clearly, low pass filter, right? Low pass, here the low pass filter, this is on x-axis of frequency, on y-axis it is a signal transmitter. The same it is x-axis frequency, on the y-axis it is a gain. The low pass filter means it passes only low frequencies. That is from 0. That means here the low pass filter in this low pass, in this only, the name itself only low pass. That means it passes only low frequencies from 0 to up to certain level. That is, here see, this is the certain level. Up to this level only, this low pass filters allows the frequencies from a signal. And the other remaining, that is above the cutoff frequencies, are a reject. This is a reject. See here, this is a reject. The other, that is the other frequencies from a signal, that is the above the cutoff frequency, or we can also call it as a roll off frequencies, is reject or eliminated or deleted. So these frequencies of a signal are unwanted. These are unwanted. This is not required. This is not required. These frequencies from a signal is not required. Right. So low pass filter is nothing but it allows only low frequencies from 0 up to certain level. That is, and above the cutoff frequencies from a signal are eliminated or deleted. That is called a low pass filter. Here in the name itself, low pass means it allows only low range of frequencies from 0 to up to certain level. Right. And this low pass filter is also called as a lag network or integrating network. Lag network or integrating network. The next we'll go for the next one. High pass filter. See here in the name itself only it is there, high pass filter. High pass filter, all of you know that. So same similarly low pass filter. Here high pass means it allows only high level frequencies from a signal, and it eliminate all the low frequencies from a signal. So that is called high pass filter. So here the high pass filter is here, it allows only the high frequencies. See here, the above the cutoff frequencies, above it allows, here this is the above the cutoff frequencies. It allows the high frequencies to the level up to the infinity, and it rejects all the low frequencies below the cutoff frequency. Here that means the high pass filter, see if you see here, it allows only the high frequencies to the value up to infinity, and rejects all the low frequencies below the cutoff. This is the below the cutoff frequencies. It eliminates or delete the lower frequency, that is below the cutoff frequency. That is called high pass filter. High pass means it allows only high frequencies from a signal. All the other remaining low frequency signals are eliminated. It is also called as a differentiating network. It is also called as a differentiating network. Now it is clear. The next we'll go for the next one. Band pass filter. Here in the band pass filter, band pass. That means here, if you see in the name itself on band pass, that means only certain band of frequencies from a signal are passing or permitting to transmit. The other remaining frequencies of a signals are eliminated. See here in this, if you see clearly observe, it allows only a certain band of frequencies from a signal. That is within a specified band. All the frequency within a specified band is to be transmitted, and the others, that means and the others are rejecting. See here, if you see here, this is only the pass is only a certain band of frequencies only, and the other remaining frequencies from a signal are rejected, or eliminated, or deleted, right? So only here in this, only certain band of frequencies from a signal are passing or transmitting. And if you see the next one, band stop filter. In this band stop filter, here, see here, band stop. Only certain band of frequencies from a signal are stopped, or rejected, or eliminated, or deleted, and the remaining frequencies of a signal are transmitted. See here, if you see clearly, this is the only range of frequency. That is, if you see here, only certain range of frequencies from a signal are rejecting. See here, this is a rejecting. This is a rejecting. Only certain band, certain specified band of range of frequencies from a signal are stopped, or rejected, or eliminated, or deleted, and all other remaining signals, all other remaining frequencies from a signal are transmitting. That is called band stop filter. So this band stop filter we can also known as band elimination filters. Band elimination filters. Again, I'm repeating. See here, low pass filter means it allows only low frequencies from a signal from 0 to up to certain level. That is up to cutoff frequency. Above the cutoff frequencies, that is frequencies from a signal, are eliminated. That is called low pass filter. High pass filter means it allows only the high frequencies from a signal, that is up to the range of infinity, and all the low frequencies from a signal are eliminated. Band pass filter is, that means it allows only certain range or a certain specified band of frequencies from a signal only it passes, or it permitting. The other remaining frequencies from a signal are eliminated. And in the band stop filter, only a certain band, or a specified band, or a certain range of frequencies from a signal are stopped or rejected, and the other remaining are frequencies from a signal are transmitting. That is called band stop. So in the examination, you have to draw these figures clearly. Then next, so are you understand this one? No, here we are discussing the signal, right? The signal is from the signal, the frequencies from the signal we are eliminating, and then we are passing certain band. Here the signal, where the signal will comes. You understand? Here the filter we are seeing in operational amplifier, we discussed in the operational amplifier. The signal is amplified with the help of some through mathematical operations, that is addition, subtraction, multiplication, division, right, differentiating, integrating, like that, so many. So here all we are doing on the signal, right? See here in the filter, for example, filter, here the ETLO signal, where the signal it is coming, that one who will discuss. That is the next one, signal conditioning. Where the signal, already we discussed in the unit 1, that mechatronics total picture I clearly mentioned. Here the syllabus framed, it's very, very good mechatronics. Actually, if you go for thinking in depth what we studied for imagination, if you go for unit 1, in unit 1 what we discussed about the mechatronics, the key element of mechatronics, key elements of mechatronics, and advantages, disadvantages of mechatronics. And also we discussed the levels of mechatronics. And also we discussed the various sensors and transducer, right? That is the actually the first point in a mechatronics product. That is the first part. In a mechatronics product, what we discussed in unit 1, various sensors and transducers. Already I given a clear picture about a mechatronics picture, what are the components are there, the mechatronics key elements, the mechatronics or otherwise mechatronics design process. I clearly explained clearly. The first part is sensors and transducers. And the second part is what? Anybody? Second part is what? Here, for example, in a device, anyone can message the chat box. Here, why? Here, unit 2, we are discussing so many diodes, transistors, diac, triac, right? FET, field effect transistor, that is MOSFET, JFET, and LED light emitting diode, and we discussed operational amplifiers, filters. So why here we are discussing all the things? Anybody? Here in unit 2, we are discussing all the things. Again, shall I go to the unit 1? Shall I see shall I give the clear picture to you? Okay, I will share, just wait. One minute, please wait. So now I am sharing. See here in this, if you see, observe clearly what we discussed here. This is a mechanical system, right? In the mechanical system, this mechanical system, and then here signal conditioning, right? So just I am remembering you here in the signal conditioning. See here, filters, analog, or it is visible to you? It is visible to you. Anybody can chart. It is visible to you. Anybody can chart. Yes. Okay. Right. If you see, uh, see here, yeah, this is unit 1 we discussed, mechanical system. Here it consists of sensors and transducers, right? From this already we discussed, these are all the things in unit 1. From the half of the unit 1, we discussed various types of sensors and transducers. Here see, the output from the sensors is given to the signal conditioning. Here the signal, here in the unit 2, we are completely discussing about the signals, right? Where the signal is coming, here the signal is coming from the sensors and transducers. Remember this point. Here the unit 1, it is designed very goodly, the syllabus. The unit 1, first it is given clearly about the mechatronics and key elements of mechatronics and mechatronics design process. And then we discussed various sensors and transducers. That means in the various sensors and transducers, we are getting the output. That output signal is sending to the signal conditioning. Here, see here, the signal conditioning. This signal conditioning is nothing but the signal conditionings are amplifiers are signal conditioning, filters are signal conditioning, and various transistors, resistors, or diodes. So these are all coming under signal conditioning. See here, in this signal conditioning, it's clearly mentioned filters, analog to digital, right? Digital to digital amplifiers, discrete circuit. In discrete circuit, so many resistors, transducers, like that. Are you understand now? Here the signal condition, here we are discussing completely in unit 1 signal condition, signal, right? So many times we used the word signals. So where the signal it is coming, the output from the sensors and transducer is not satisfactory. If it is not satisfactory, then only we are sending to the signal conditioning. What is the meaning of the signal conditioning here? Here the signal is conditioned and it is making it correct, which is useful or satisfactory. With the help of the elements, what you used, that is amplifiers, filters, or attenuators, what we discussed, attenuators, some mathematical operations, maybe resistors, transistors, diodes. So these are all making it makes the signal correct. What is the signal? It makes the signals correct means the output from the sensors and transducer. Here the signal from the output from the transducer or sensor is not correct. So that we are making the signal correct with the help of these signal conditioning devices. Signal conditioning means here the signal is conditioned by using some amplifiers, filters, some other. So that is called. Here see in the signal conditioning, it is clearly mentioned filters, amplifiers, A to D converters. A to D converter is nothing but from one form of conversion. This is also called a transducer. A to D converter, analog to digital conversion. D to D, digital to digital conversion. Discrete circuits. As in the circuits, there are so many resistors, transducers, diodes are there. That is now you got the clear picture. Now I am this one by one we will discuss, and then unit 3. This one we will discuss. Digital, and like that we'll discuss all the things. This is the completely flow chart. It's very, very good, right? So now in the unit 1 we discussed the mechanical systems, this is, and unit 2 we discussed this one we discussed. Likewise unit 3 and unit 4 we discussed like that. A total complete unit we discussed all the things. And lastly, we have to go for an example of a mechatronics design process, what you studied in the previous 5 units. We have to go, whatever you studied, the components we have to implement there. So this is a very, very good course. Now, okay, right? Now I am stop sharing. Then we will go for this our class. So now we will come to the right. We will come to the signal conditioning, right? Analog signal conditioning. Right. This uh, analog signal condition. Now I will tell. Right. So here, first, what we discussed in the general measurement system components. This is a sensor transducer. What I shown to you. So here, the input is a physical phenomenon. That means it's a detector transducer stage. That means it detects the sensor. Input is the physical phenomenon. That is the physical variable from the environment. Here the transducer, here the transducer, it converts one form of the signal to the another form of the signal. Here this is a transducer. It converts one form of the signal to the another form of the signal. So that the output from the transducer, that is called a signal. It is in the form of electrical form. So this is not satisfactory up to the mark. So that's why we are sending to the signal conditioner. Signal conditioning. Here the signal, the output signal from the transducer is conditioned through signal conditioner, that is by using some components, maybe amplifiers or filters, or maybe some resistors, capacitors, like these are all the components, circuit components. So, and the output here, this is the first stage. First stage here, what is the first stage here? It detects the variable from the environment, and then that is converting to one form to the another form, that is called transducer. The output from the transducer is a signal, which is an electrical form. That is not the correct. That is not the correct one. That is not satisfactory. That is not useful. So that's why we are sending that output signal from the transducer into a signal conditioner to make the signal correct. To make the signal correct. Here in the signal conditioner is making the signal in the, this is the intermediate stage. Here it makes the signal from the output into correct form before into the data present. Here in the data presentation unit, data presentation is nothing but recording, displaying, monitoring. We can monitor through the physical variable, the output, it should be correct or right. So here in the data presentation, the output from the signal conditioner is a data presentation unit. In this data presentation unit, indicator, recording, displaying, monitoring, we can go for like that. Is the data just for a generalized measurement system, that is for a generalized mechatronics product. Right, now we can clearly understand these are all the things. Right, now we will go for the next one. So now it is clear. This is we hear the signal conditioning. Now we are going to discussing about the signal condition. Here in this signal conditioning, all the whatever we discussed in unit 2, all the components are there. All the components, that is the fundamentals. What we discussed, all the things are the fundamentals. So where in your having your brain having some innovative idea to develop a mechatronics product. So this is my imagine that is this is whatever the syllabus is completely worthful syllabus. So anybody having some innovative idea to develop a mechatronics product. So this whatever in this from unit 1 to unit 6 you studied the concepts, that is full-fledged. It's very useful to develop a mechatronics product, that concepts. Right, now next. Right, now it's clear. Are you understand this one? Sorry, signal. Next, we will go for the next one. Right, signal conditioning. Here the signal, what I told you that, right, it is defined as a process of modifying the output signal from the transducer. So what are you shown? See here the output signal from the transducer is entering into the signal conditioner. Here it is defined as a modifying the output signal from the transducer into what is into useful and satisfactory by using amplification, attenuation, non-linearization, linearization, multiplication by another form. The signal is conditioned by using all these mathematical operations. That is modified, the signal is modified, the signal is amplified, the signal is making correct. That is called modulated into a desired level of a signal. That means our required level of it. That means satisfactory, which is useful without any error. So that is called a signal condition. That is called a signal conditioning. So here, what is the necessity of the signal conditioning? So now I will clearly explain you. The signal is too noisy due to some electromagnetic interference, disturbances. If the signal is too noise, means we cannot get our output in the correct form. For example, take the TV. For example, suddenly the rain is coming. We cannot get the voice clearly. We cannot get the sound clearly. So what you have to do? Again, you have to go with some fine tuning with the help of the remote. Then up to your comfort, you can adjust like that. Fine tuning, you can go for fine tuning. Am I right? So like that. So if the signal, for example, even if you take the radio, some disturbances are coming. So what again we have to go for fine tuning by regulating, right? The frequencies from the signal, the frequencies of. So likewise, if the signal is too noise, that means the disturbances, then we can go for signal conditioning. Can go for signal. Why? That is the necessity. That is the here the necessity of signal conditioning due to this following reasons. One by one. This is the first one. The signal is too noise. If the signal is too small, that is a millivolt range. So that means we need amplification. So if the signal is very is too small, it is not readable, then we have to go for amplification. And the signal is non-linear. We have to convert into linear. I understand. The signal is non-linear and it is required to be converted into digital form, or it is converted into a linear form. And if the signal is analog and we have to convert into a digital form. If the signal is a digital, we have to convert into analog form. See here, the digital, and we have to convert into analog. And it improves the quality. This is it improves the quality of the signal. That means this signal conditioning, whatever we discussed, the devices, electronic devices, these are all making the signal strengthen. That is to improve. Here it is written clearly, improve the quality of the signal. Improve the quality of the means it strengthen the signal. It strengthen the signal. So now again I'm repeating, all of you listen carefully. What is the necessity of signal conditioning? Here the signal conditioning means amplifiers, filters. These are all transistors. These are all signal conditioning components. So signal is too noise. So then we have to make the signal without noise with the help of the signal conditioning. And signal is too small. We have to make it amplify to make the signals correct. And a non-linear, we have to make a linear. And if the signal is an analog one, we have to convert into digital. In some applications, we need digital signal. In some application, we need analog signal. That means we can convert analog signal to digital, and we can also convert a digital to analog. These are all coming under signal conditioning. And it may be required to improve the quality of the signal. It's very important. That means it makes the weak signal into a strengthened signal. That is a quality signal. So now next one, are you understand all the things? Next, what are the process adapt? What are the process adapted in signal condition? See here, protection. See here, this is the first one is the protection. 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 I think all of you know the protection, right? All of you know the protection. Here, the output signal from the transducer is very high, and it creates damage to the next component or element. So that is called protection. See here, for example, the output from the transducer, what we discussed, the signal coming from the output is very high. So this signal, for example, high voltage current. For example, in our household appliances, the current fluctuates. If it is high voltage, what happens? All the components will get damaged. For example, a TV without stabilizer. Think 1 second. TV without stabilizer. Fridge without stabilizer. AC without stabilizer. That means this, what are the process adapted in signal condition? Protection. Protection is very important. Here, for to protect a component, valuable component or valuable element from the high signals from the transducer. So we have to make it correct. So by what here, all of you listen here, see here. Sir, when the high voltage or current signal are fed to the microprocessor, it will get damaged. So to protect for that, what we have to do? We have to employ a series of current limiting resistors. Here, see here, we have to arrange a series of resistors. So that way, the current signals automatically will come into correct level. See, a resistor fuses to break. For example, see here in the household why here, why you are arranging fuses, fuse. So here to protect from high voltage, high current signals. So when the fuse breaks automatically, then automatically whatever in a household components will protect from the fuse. So here, if you see in the TV, in the board, there are so many electrical components in the circuit board. So here, if there is a one component is a very good, valuable component to protect that valuable component from high signals, we have to arrange before that a number of series of resistors, diodes, transistors like that. So here and also here, see here in the step down transformers. Here unexpectedly from the high voltage signal, for example, in the street, the transformer will feel it. So what is that? To protect from signals, high voltage signals, we are placing a transformer. It's a step down transformer. If the voltage is too high, how to step down? And using voltage limitation circuits. That means here the first point is, and the process adopted in signal conditions, protection. We have to protect a valuable component or some other from the high signals. We have to incorporate. So here a series of current limiting resistor, fuse to break, and also step down transformer, and also voltage limitations. That means various number of transistors, diodes. These are all the, here the diode is also a voltage regulator. I already told you it's a regulate the voltage. So regulate the voltage. So now the second point is getting the right type of signals. Here, if the output signal from the transducer is of analog type, right type, that means is analog type, it is not your desired type of signal. Then we have to, needs to be converted into DC voltage or current. So getting the right type of signals. Here the output signal from the transducer is not a right one. We have to make it the signal into a right signal. Then we have to need to be converted into a DC voltage or current. So the time is over. No? Oh, okay, right. I will end the class within 2 minutes. So now getting correct level of signals. Here the level of the output signal is too small. So that's why we need, it is very difficult to measure such a low level signals. Here getting correct level of signals. If the output signal is too small, that is very difficult to measure such low level signals. So for that we have to go for implementing the operational amplifiers are widely used. So on the third one, the fourth one is elimination of interference. That means if the signal is a noise or a disturbance due to electromagnetic interference, there we can use the filters. And the fifth one, manipulation. For example, if it is a non-linear, we have to make it a linear. That is called manipulation. Here, total 5 processes are there. The first one is protection. Second one is getting right type of signals. And the third one is getting a correct level of signals. And the fourth one is elimination of disturbances. And the fifth one is manipulation. In the protection, we have to protect the valuable component from high signals. So for that, we have to arrange a step down transformer or a number of series number of resistors, fuses, like that, and getting right type of signals. If the signal is a analog type from the output transducer, then we have to make the signal into a correct, that is a right type, that is how to convert into DC voltage or current, and getting a correct level of signals. The level of the output signal is too small, it is very difficult to measure. So for that, we have to make it amplify with the help of the operational amplifier. And the elimination of disturbances or noise signals due to the electromagnetic interference. With the help of the filters, we can eliminate the disturbances. And manipulation, we can manipulate the signal. If it is non-linear, we have to make it linear, right? So now display, now I will take the attendance. So all of you respond one by one. All of you respond one by one. Chat box, just you have to message the chat box, right? Number 1, 3, 4, 5, 7, 8, 9, 5 present, 8, right, present, 8 present, 9, 10, 9, 10, 11, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 24, 24, and 25, 24 option, right? 25, 26, right? 27, 28, 28, 29, 30, 31, 31, 31, 32, 32. One minute. 32, 33, 34, 34, 35, 35, 36, 37, 38, 38, 39, 39, option 39. 41, 41, 42, 43, 44, 45, 46, 47, 46, 45 option, right? 46 present, 48, 49, 50, 51, 52, 53, 54, 54, 55, 56, 55 absent. And 57, 50, 50, 60, 61, 60, 61 absent. 61 present. 5, 66, 64 plus 65, 66, yes, 67, 68, 68, 69, 70, 70, 63, okay, present. 69, 70, 70, I'm asking about 70, 73, 74, 75, 76, 77, 78, 79, 78, 79, 80, right, present. 81, 83, 81, 83, 81 option, right? Right, 84, 84, 85 present, okay, right, 88, 89, 89, 90, 91, 90, 91, 90 absent, 92, right, lateral entry 1, right, 2, 2, 3, 4, 4, lateral entry 4, 5, 6, okay, 6, 6, lateral entry 6, 6, 8, 8, 8, 9, 10, 11, 12, 12, 13, 14, 15, 16, 16, 17, 18, 19, 20, 21, 21, 22, 23, 24, 25, 26, 27, 28, 27, 28, 28 absent, 29, 30, right, 29, 30, 31, 32, 33, 34, 35, 34 absent, 35, 36, 37, okay, right, 35 present, 37, 38, 38, 38, 39, okay, right, 40, 40, 40 option, 41, 43, right. Here the option is just I will read, all of you go through it. 9, regular 9, 13, 24, 39, 45, 55, 60, 70, okay, 70 present, 70, 73, 81, 84, 90, lateral into 6, 16, 17, 25, 27, 28, 90 present, okay, 27, 28, 30, 34, 40. These are the absentees. Anybody else? And now who will end the class? Again, I'm repeating. 337 337 lateral entry. ఎవరికి పవర్ కట్ అయిందమ్మా? 17 okay, 20 present already, given present already. 390 is also present. Okay, we will end the class. Thank you all of you. Yes, 3-2 exams. No, 3-2 exams are not there. JNT Kakinada is not not given any information regarding 3-2 exams. Okay, only final year exams only. Correct. Only final year and supplementary examination. Correct? Okay. Thank you, all of you.